Yeah. Hi, I'm John Waters, and this is The Creep.
Good evening, and welcome to another episode of Soil Creep. My name is Pert Hedgson.
And I am Ben Ferris, and we are here today to discuss the processes involved in soil creep and show you how to identify soil creep out in the wild. Soil creep is the slow downhill movement of particles that occurs on every slope covered with loose, weathered materials.
But the scary thing about this phenomena is that it happens at a rate that is not noticeable to the naked eye. Where are you? Where are you? Show yourself! Show yourself!
This downhill movement of soil and regolith is due to the force of gravity and resisted by the force of friction. The forces of gravity and friction are in balance at the angle of repose, the maximum slope angle that unconsolidated materials can maintain.
If the angle of the slope happens to be altered, then the acting forces will be adjusted. For example, if the slope of an angle diminishes, then the rate of material removal, or soil creep, will slacken. This is because the force of gravity has been reduced.
The exception to this rule is the addition of moisture to a slope. Water can reduce the friction and increase the mass, therefore the gravitational force, thereby reducing the angle of repose and causing soil creep without altering the angle of the slope.
Wow. Oh, here's a fun fact. To an observer, soil creep may appear to be one continuous movement, but in actual fact, it's really the sum of numerous minute movements of slope material caused by the force of gravity. And being that water plays such a significant role in soil creep, it is understandable that the rate of creep is known to vary depending on season, and can range from centimetres per week to centimetres per year.
Was that W.E.H. Cullen?
1963, baby!
Nice. For most cases of soil creep, the only evidence available to humans that soil creep is out there, terrorising our slopes, is the slow but persistent tilting of trees, poles, gravestones, and other objects set into the ground on hillsides.
Do you like how I sing a love song? Do you like Vincent van Gogh? I like to walk the streets at midnight. I wanted you to know that I'm a real...
The most important process producing creep and determining the rate of creep, aside from direct gravitational influences, is the distribution and characteristics of the pore space in the soil aggregate. They exert a restrictive influence and determine the nature and magnitude of the particle displacements. Macroscopically, the motion of the soil particles include a rate of flow on the hillside slope proportional to the surface gradient.
Simply put, composition of soil aggregate determines how well water can drain down the slope. The better the drainage, the less effect the creep will have. Therefore, having higher amounts of impermeable materials, such as silt and clay, are more prone to soil creep than soils with larger grain sizes that allow for greater filtration and less oversaturation. Climatic conditions play a part in contributing to the rate of soil creep as well. Areas prone to colder conditions are likely to experience the impacts of frost heaving, otherwise known as freeze-thaw. This isn't such an issue here in the local Illawarra area, but it's definitely worth a mention.
Definitely. As interstitial water freezes, surface particles are forced up and out perpendicular to the slope. When let down by melting, these particles are drawn directly downward by gravity, and they are thereby gradually moved down slope. Other physical aspects worth considering when analysing soil creep is the wedging action of root growth, bioturbation from burrowing animals, the wetting and drying of soil layers, agriculture, and the devegetation of land.
Be mindful of the landscape, as it will often give you clues as to why soil creep is occurring.
Okay, so now that you have first-class knowledge of what soil creep is, it's time to take you out into the field and show you the devastating effects that soil creep has on everyday life.
But before we continue, we must apologise. We know you were promised an instructional video on how to infer the rate of soil creep.
Unfortunately, though, we will not be able to give truly accurate information.
You see, in order to infer creep rate, you need to first know the year that the affected fence, house, signpost, etc. was built. You can then divide the amount of displacement suffered by the affected object by how old it is.
A simple equation to perform, but only possible if landowners and the council were willing to cooperate. Our wonderful producer worked tirelessly to acquire the information needed, but was ultimately refused by the higher powers.
Here is a copy of his email to the council as proof that he is not some dreadlock slacker.
Not like this, so lost and in question. So much has been left unsaid. You fill in the blank spots, I guess at the hard parts. Were you like a
Moving on, we still want to take you out into the field to witness some real-life creep and see how field measurements are taken. Due to the fast-paced, high-intensity nature of soil creep, we won't have a lot of time to explain exactly what we're doing out in the field. So please, sit back, observe the field procedures being performed, and we will explain the entire process step by step back here in the studio.
Up first, we're going to take you to Bulli, where we'll be analysing the effects of soil creep on the southern side of Hospital Road. Oh, wait. Just before we head out, let me remind you that we are trained professionals and you should under no circumstances attempt what we do in real life. Please, it's for your own safety and the safety of others. Don't do it. Okay, so here we are on the southern side of Hospital Road in Bulli. And as you can see, the soil creep here has left a devastating impact on the landscape. I mean, look at that poor tree. Gruesome, isn't it?
Kurt and I will now attempt to get in nice and close to the action and take some measurements.
Let's go. Welcome back. We hope you enjoyed your first little taste of soil creep in the field.
So, what you just saw is the best method for identifying soil creep, which is by using indicators such as bent fences, gravestones, or in this case trees.
I believe we had a montage of examples on display earlier for you, so you'll now be aware of what to look out for.
The next step in the process is to work out the slope of the area, and to do this you will need a couple of tools, and just so happen to have them here. A tape measure, a carpenter's level, and a measured piece of wood.
This one's a meter.
So what Pert and I were doing out in the field was using these tools to find the exact measurements, and then to calculate the slope of an area, you will need to employ some simple trigonometry, rows over run to be precise.
We then take the average to find out the overall slope. For this location, the slope of the hill is 40.8%.
A significant slope. And no surprise that some soil creep has occurred, because as you recall, the steeper the slope means the stronger the gravitational force applied on the material.
The second set of measurements we took were in order to measure the displacement of the affected objects. The measurement required in conjunction with its age to determine the rate of soil creep.
The average rate of displacement at the site is 50 centimeters, and if you're a better researcher than producer Jake over here, then you will be able to find the age and calculate the rate of creep.
Yeah, definitely. We're now going to carry on in the same fashion for the next two locations, so you better buckle up, because we're now headed to Cope Place in Bulli.
Welcome to Cope Place in Bulli. This is the most extreme case of soil creep you are going to witness on this video.
And perhaps your entire life.
The devastation in this area is near indescribable.
It's out of control.
To show you just how bad it is here, the council have just accepted that they cannot contain the creep and have simply not bothered to build gutters because they will only be ruined. Instead, they have crudely tarred up the embankment as a cheap alternative.
Anyway, let's get some measurements. And welcome back to the studio. Same drill as before. The first set of measurements taken are to record the angle of slope. An average is taken, and the overall result for the area is 52.5%.
Second measurements are to determine the amount of displacement suffered. No need to remind you of Jake's failure again, but we will. We don't have the age of construction and therefore cannot complete the assignment. But just from looking at the evidence here, as well as the steepness of the slope, you can tell a significant rate of creep occurring.
Moving on, we're now going to visit Joseph Street.
Once again, we had some issues here where the residents of the house didn't want us filming and spending too much time in their front yard.
However, they were kind enough to let us take some quick measurements and some photos of the contaminated area.
When asked if they had any idea how old the fence in question was, they couldn't give us a definitive answer, but were able to tell us that the area was seriously affected when they moved into the property 7 years ago.
The angle of slope in this area is 45%.
As you are about to see, the displacement at this site was quite difficult to calculate because the amount of soil movement has completely destroyed the small fence, and the rubble has since been cleared away. Our final measurement gave a displacement of 93 centimetres.
Now, for the sake of having an answer, say the fence is around 15 years old, then the rate of creep for this area is approximately 6.2 centimetres per year.
Please enjoy the lovely photo montage. There you have it. That's about all the time we have. But before we take our leave, let's just recap what we've learned.
That's a really good idea then. Soil creep is the result of gravitational forces overcoming the resisting frictional forces on a hill slope.
Furthermore,
Those gravitational forces are stronger on steeper slopes
meaning that soil creep will occur
at a faster rate.
on steeper slopes,
This is why we measure the angle of slopes when we're out in the field.
because we know of the relationship between slope angle and soil creep. Knowing the slope at a work site is a good indicator of what to expect in terms of soil creep without having to do expensive laboratory testing.
Soil characteristics, such as its grain size, are the other major factors to a soil's ability to creep. The composition of sand, silt, or clay determines the soil's ability to hold and release water through its pores. The less capable a soil is of allowing water to flow freely through it, the more susceptible that soil is to soil creep.
Several other physical factors contribute to the rate of soil creep: climatic conditions, seasonal variation, bioturbation, and
Human activity.
Indicators such as bends in trees, signposts, and fences are the only real evidence available to people that soil creep is at play, because the rate of this nuisance is far too slow to be witnessed in real time.
if, for example, you notice that your retaining wall is starting to lean and you are able to recall the year that it was built.
Then it is a good idea to calculate the rate of creep.
To do this, you simply measure the amount of displacement and divide it by how old the structure is.
100 millimeters of displacement divided by 10 years old equals 10 millimeters per year of movement. Once again, my name is Pert Hedgeman.
And I am Ben Ferris. It's been an absolute pleasure sharing this journey with you.
By watching this video, you have automatically been accredited as a certified creeper. Your certificate will surely arrive in the mail shortly. In the meantime, if you do have any more questions, please don't hesitate to contact us. We'll chuck some deets up on the screen for you. Thanks for watching.